Hi everyone, and welcome to the fourth edition of our Cairo Bootcamp. So we have had three different bootcamps. The first one was in 2022, the second was in 2023, then the third was last year, and this is the fourth edition. So basically, the idea of this bootcamp is to help builders from Africa learn about Cairo, Starknet, and also get good and also start earning in the ecosystem. And today and for this bootcamp, we are going to have a very different structure from what we have been doing. Normally we do one classes every week, but we are changing the game. But I would allow Sarah to talk more about this and also share a very good detail on this. But just be rest assured that this is going to be amazing and we're going to make it quite exciting for everyone to get into the ecosystem and see how amazing Starknet is. But Sarah is going to share very good light on this.
Okay, hi everyone. GM, I trust we are all doing great. Please, can you confirm again? You can see my screen well.
Yeah.
Hi, Paul. Please, can you confirm that?
Yeah, I can see, yeah.
Okay,
Yeah,
thank
yeah,
you.
yeah.
Yes, so welcome once again to Cairo Bootcamp IV. We are excited to have you here. This bootcamp is going to run from May to July 2025. But I'm Sarah, I'm Oluwatosin Sarah. You can call me Sarah. A smart contract developer, a technical writer. I also do blockchain education, putting out content and all of that. So if you have any uh, any problem or any issues you encounter during the bootcamp, you always reach out to me or any of the tutors, right? Okay, so shortly about the bootcamp. So the bootcamp is a Starknet Africa initiative to onboard developers to the Starknet ecosystem. So we could have more African builders, right, in the Starknet ecosystem. So the bootcamp is going to be a 10 weeks bootcamp. You're going to be having 7-week course taught live, right? 2 week for your project work, and there's going to be like a full prize for you to win out from. So the idea of the project work is to show what you've like been able to learn over the course of the 7-week training sessions that you've been going through, right? And then we're going to have one week that's dedicated for graduation. You're going to have your certificate, which is going to come as a spoke, an NFT, right? For people that that came top in the project work, we're going to have your awards distributed to you and all of that. So we also have some events planned, like what's next after the boot camp and all of that, because we do not just what's next where you can fix yourself right after the boot camp. So the sessions are going to be 4 hours per week. Supposed to be Tuesdays and Thursdays from 5 p.m. UTC to 7 p.m. UTC. So we have 2 hours, 2 hours on Tuesday, 2 hours on Thursday. That's 4 hours, making 4 hours per week. So you have access to chats. If you have questions, there's going to be question and answer. Your tutors are going to ask questions from you, so you can also answer, right? So that's like a form of discussion. So we can know that you're actually following up, right? And if you have any questions, you can always drop it in the chat box. And if maybe you encounter a blocker outside of the class, you can always drop questions on the Starknet Africa Telegram group or on Colonies. Yes. So you're also going to be giving weekly homework, right, by the tutors. And we are also going to be sending out forms for you to fill out to submit your assignment. right? So make sure you join the community on colonies. I know some people have been like having issues signing up on colonies, but if there is any issue that you encounter, you can always tag Darlington on the Telegram channel. It's always open to help you navigate that. And then, yeah, so this is the link to joining the Telegram Starknet Africa Telegram channel if you're not on the Telegram channel yet. And also make sure you you subscribe to the YouTube channel, Starknet Africa YouTube channel. That is where we're going to be posting all recorded sessions, so you can always catch up after the class and all of that. So we have 7 live sessions, like I said, so which is going to run through 7 weeks, right? We have fundamentals, which you're going to be doing today. You are here. Fundamentals for this week 1, today's session 1, and tomorrow's session 2. So the fundamentals is going to cover everything from what is blockchain, zero knowledge proofs, account abstractions. You basically just getting started in the Starknet ecosystem, right? Which will be handled by Cyndie. She's here. And then we have Mastering Cairo. Is going to you're going to learn the basics of Cairo, what Cairo programming language is, and get in depth to like data types and structures in Cairo. Then week 3, you're going to be building on Starknet, how you can build on Starknet, how you can write Starknet smart contract, how you can deploy contract on Starknet, and all of that. Week 4, you're going to be learning Starknet development tools and frameworks. We have a lot of tools, development tools for developers, and the frameworks on Starknet that you're going to be learning them, Dojo, all the CLIs and all of that you need to learn. You're going to be learning week 4. So for week 5, we have advanced Starknet contracts. So we're going to be taking you a little advanced from what you've learned from building on Starknet in week 3. So you should buckle up, right? Then week 6, you're going to be learning how to test your smart contracts. It's very important. You cannot just like write smart contract without auditing. You need to like learn how to secure your smart contract, how to test your smart contract to ensure everything is working well, right? Which we'll be covering in week 6. Yes, and then week 7 is front end. You need to know how to connect. You can connect your smart contract with the front end, how you can make everything work together to integrate together. Yes, so if you want to like check like and you want to like get an overview of everything, like the detailed breakdown of each of the sessions, you can click. We have everything on Notion. Everything is transparent there, is on Notion, so you can get that. So we have our tutors. We have Cyndie Kamau, which she would be taking week 1 and week 3. Hi, Cyndie. Are you there? Can you introduce yourself just shortly?
Hi guys. My name is Cyndie Kamau. I'm so happy to start with you guys today. And yeah, I hope we have a very lovely session. Yeah.
Yeah, thank you. So we also have Victor, who will be taking week 2, Mastering Cairo. Hi, Victor, are you there? Can you please introduce yourself shortly?
Um, Hello everybody. This is
Hi.
Victor, country cousin. So I'm looking forward to having our session with you in time to come. Meanwhile, enjoy today's session. Thank you.
Yeah, thank you, Victor. Hi, Nathaniel. So Nathaniel will be taking us on Starknet tools and development frameworks. Hi, Nathaniel, can you introduce yourself shortly, please?
Yeah, hello. It's amazing to be here, and I'm so excited to see what we will learn together. Looking forward to have us around. Thank you.
Yeah, thank you, Nathaniel. Hi, Kaswini. Good afternoon. Oh, sorry, good day. So let's hear from you. Kaswini be taking us on testing smart contracts and advanced Starknet contract. Yeah, Sweeney, please can you introduce yourself once do you?
Hi everyone, I'm Kaswini Ojukwu. It's gonna be an amazing session, so let's get ready to fire down. Yeah.
Thank you. All of you are not telling us I'm a blockchain developer, this and that, but I mean, all of them, they are into blockchain. Yes. So then we have our fifth tutor here. It's going to be taking us on front-end integration. Hi, Mano, are you there? Can you introduce yourself, please? Is Mano on the call? Okay, so as not to waste our time, I'm not sure it's right here, but we'll be taking us on front-end integration, right? And please, if you have any questions, please do not hesitate to ask them. Drop your questions in the chat box. No question is stupid. Please ask any of your questions, so because we want to make sure you get most out of this bootcamp. Yeah. So we have this scoring system, just as you have your scoring system in college, in school, and all of that, so we can know the kind of certificate would award you that you'll be given. So the scoring system is going to be based on your homework and your performance, right? So you will receive one homework per week, right? And it's going to be 7 weeks in total. That's 7 homework. So each homework is going to be awarded 10 points. So we're going to have total score, which is 70 points, right? So the course completion, we have 3 categories of certificates. Spoke, like it Starknet proof of kudos. That's going to be your certificate, right? We have 3 categories. We have Basecamp attendee, which is going to just show that, okay, you just attended the Basecamp, right? You were present, you registered for the Basecamp. So that means you're going to have attendance that is greater than or equal to 25%. That means at least you attended 7 out of 14 sessions. We're going to be having 14 sessions in total because there are 2 sessions per week, right? So you being awarded Basecamp attendee means you only attended at least 4 sessions out of 14. So Basecamp graduates, you have more attendance. You attended at least 7 out of 14 sessions, and then your score point from your homework is greater than or equal to 30 points. And then we have the Basecamp graduate cum laude, which is you passing with distinction. So that means you have attendance that is, you attended almost all the sessions, right? And then your score point, you have greater than or equal to, it's supposed to be 50 points though, but we have 48 points. So this is how we're going to award this spoke to all the participants. So right now, I don't know if you have questions before I hand over to the tutor that's going to be handling today's session. We're running out of time already. Any question? Any question? Okay, I'm going to, okay, someone has already, thank you, country cousin. Okay, at this point, thank you guys for listening, and please ask your question. Okay.
Good evening, ma'am. Good evening, ma'am. Can you hear me?
Good evening. Hi, Joseph. Yes.
Okay. Please, I wanted to ask, will the live recording of the sessions be available after the session, so that if by any means we miss the session, we'll be able to access the class after the session?
Yes, definitely. All sessions will be posted on YouTube, and once we post those sessions on YouTube, we're going to alert you. You're going to know on both on the Starknet Africa channel, on colonies, even on our Twitter page. You're going to be aware of that. Just make sure you subscribe to the Starknet Africa YouTube channel. The link is here, so you can always be notified when we post new videos of the sessions. So if there are no questions, there are no more questions, and if there are questions, you can drop them in the chat box. I'm going to be handing over to Cyndie, so she can take over for the fundamentals. Thank you, guys.
Thank you, ma'am.
Okay, just a second. Okay, thank you so much, Sarah, for that really great introduction. And welcome everyone to the first to our first session of the bootcamp. I hope everyone is as excited as I am. Today, the whole aspect of this blockchain of this session is we are going to go through the blockchain. We're going to go through principles of blockchain. We're also going to go through ZK, and then I have some really nice illustrations to show you guys. So without further ado, let me just quickly share my screen. Okay, you screen sharing. Okay, so let me just put this here down. Just as can you guys see my screen?
Yes, yes, ma'am, you can see it.
Okay.
Yes, we can.
Okay, thanks. All right. Okay, so hi again. My name is Cyndie Kamau. I'm from Nairobi, Kenya. I'm a blockchain developer. I love teaching, so I also work as a developer advocate. And yeah, so nice to meet you guys today. So for the agenda today, like I said, we will first go through what is blockchain, some blockchain principles, and then we're also going to go through some ZK, and then we'll be able to connect through with our session tomorrow, where we're going to go deep into now what is Starknet, how does Starknet work, and things like adding your wallets, right? So what is blockchain? Normally when we talk about blockchain, we normally offer like a very textbook answer, like, oh, it's a digital ledger, blah, 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 blah. But for you guys to be able to really understand the why behind the blockchain, I've prepared a really great analogy that we're going to go through step by step so that you can be able to connect with principles of blockchain and why blockchain exists. In reality, right? Yeah. So the three questions I want you to guys to: what is blockchain? But most importantly, why do we need blockchain in itself, which we're going to go through today? So so the analogy I prepared today is we use Google a lot, right? Like I want to assume almost everyone here has like a Google account. You use Gmail, you use Google Photos, you use Google Drive, you use so many Google offerings, right? So I made up a scenario of this community where Cyndie, of course, Cyndie's community, right? So she just woke up, she's been using her Google services normally, but then one day imagine you just wake up and Google decide to shut everything down, right? And you can't access your Google Photos, you can't access your Gmail, you can't access all the files that you've stored in your Google Drive. So what are we going to do, right? Because they decided to shut down and they've closed everything that we had in Google. So when you check what went wrong, just a sec. Yes. When you check what went wrong, Google is a very centralized service. And what do I mean by centralized service? It's a company and they have their own servers, right? So everything that we upload and when we use Google services, essentially we are uploading all our documents, all our data, all etc. in the servers of this company, right? And we always list here Google has data warehouses, data warehouses. We don't really know exactly where they are. And it's not like I can go in there and ask Google, okay, what do you do with my data, right? I mean, of course, we normally sign the privacy notice and they have a very a very long privacy notice that they say, oh, we do this with the data, but we don't really read these things, right? We just click accept the terms and conditions and we go on, right? So we don't really know exactly what they do with all the details that we upload in various services that we use for Google, right? So simply put, as I could say, Google is the landlord, okay? So, and we're just renting out their services. So if the landlord wakes up one day and decides to kick you out of your apartment, there's nothing you can do really, because essentially they're the owner of the building. You're just renting out the space for the apartment, right? So, oh, yes. So so Cyndie and her community woke up and Google decided to shut down, and everything gets lost, okay? And it's not like they can do anything. So Cyndie gets an idea, right? What if we rebuild Google again, but instead of having a centralized authority like a company, instead of just having one company which is providing services to this community, the community is now the owner of Google, right? So everyone is able to like run Google services in the community. Everyone has a copy of their data, etc, etc. So and yeah, so she proposes this to the community, and the community is like, okay, let's rebuild Google from scratch, but we'll make it as a community. We don't have a centralized authority. We just have us. We will run the Google servers on our own, right? So yeah, so they're like, okay, yes, Cyndie, you've given us a proposal. What is the first step? Okay, so the first step would be, first of all, we need the servers to be up and running, right? But because we've decided we don't want one person essentially to be able to operate these servers only, we want each person in this community to be able to host a Google server in their house. Okay, so the first step that this community does is they decide to each person to come up to get some resources, whether it's like a server, whether it's a laptop, whether it's a phone, and plug in to the system. And they're like, these servers are now every person in this home has like a Google server which is up and running. Okay, so they're like, okay, everyone starts setting up the network. So this is like the first step, right? So they're like, okay, yes, we now have servers. Each home is running a server in the network, right? So to connect that with blockchain is the first solution that they had is, let's set up nodes. So in our blockchain terms, these servers now, they're called nodes, right? So essentially each person who wants to plug in, they set up the hardware requirements. So obviously Cyndie told them to be able to run a Google server, you need, let's say, 64 GB of RAM, you need some, let's say 2 terabytes of storage, you need this, you need that, you need a very you need internet connection, all these requirements, and then they decided and everyone set up the servers. So in blockchain, that's the same as setting up nodes in a network, right? So essentially, the way each home has its own server, that's what we call now each person in the ecosystem. When you decide to like set up a node, you're just providing services to blockchain, right? That's what keeps it decentralized, because there's no one who's like running nodes for a specific chain. It's the community which are running these nodes, right? So yeah, that's the first step they took. They decided to host the servers for Google, right? Okay. So now, once they did that, because they wanted to monitor what sort of activities is going to happen, we have these community servers. We want to, let's say, log events. Like if someone else is plugging they've come in later into the community and they want to run like a Google server. Let's do what? Like we want to log and say at this and this time, this person entered into the network and they ran a node, right? Or let's say the Google server. So they have several events that, let's say, as a community, they wanted to log in, even other activities. Example, if I'm sending this one money, or there's a certain proposal which has been submitted, etc. So what did they do? They decided, well, we have Google Doc, right? So that would be like our ledger, okay? So we'll have this global Google Doc. Everyone will have access to it, right? And everyone can be able to have the permission to edit on this Google Doc, okay? So that's what we now call like a ledger in blockchain, right? So just think of it as a very global Google Doc, which is accessible to anyone, okay? But now they hit on their first challenge. Okay, yes, we've set up the Google Doc and we've decided we're going to be noting down all the events or any actions which are being performed by the community members in this public Google Doc, okay? But what if, how do we strategize in a way that what if we have like 20 people who all want to edit this Google Doc at the same time? And if you've ever worked on a Google Doc with other people and everyone is like changing things at the same time in real time, things can get very messy very quickly, right? So when they hit that first challenge, they decided, okay, we can't just let anyone write on this Google Doc just like that, right? We need some sort of system, okay? And what if this person wants to write and the neighbor doesn't want them to edit the doc? You know, all these politics that can come with such initiatives, okay? So they decided on something we call a consensus. So they set rules, which we call in blockchain consensus rules. And these rules, we mean, like, example, what is acceptable to be added to the Google Doc? Because I mean, anyone can come and decide to spam with links which are not needed. Anyone can upload. Maybe anyone can decide. Let's say I'll write, like, example, my ingredients list that I'm going to the shop to in the Google Doc, and that's not like very important information for the community. Okay, so this is the same with blockchain. Like, you now have to set rules. Okay, just like this community decided to set the consensus rules, that first of all, if you're submitting an information to the Google Doc, it has to be this. So a valid information is like, I sent money to this one at this and this time, or I've had an agreement with my neighbor that I'll offer them services and then they'll offer me another service. So a contract like that, right, will still be uploaded in the Google Doc so that the community members can be like a witness or something. Okay, so those are some of the what we call like consensus rules. And in to connect with blockchain, it's like you're saying which transaction will be valid, which transaction will be invalid. Just like I was saying, what will go into the Google Doc, what will not go into the Google Doc. Okay, so they've set the rules, right? But we still haven't handled the scenario where everyone wants to submit something to the Google Doc. How do we maintain some sort of order in our Google Doc and be able to ensure that everything is in place, right? So that's where we consensus, which we call consensus algorithms, right? And that's what we're going to go to the next step. So yeah, which consensus? So first of all, they decided, okay, let's do it as a, let's say like a gamble, right? Let's call it like let's just call it like a gamble, okay? So if you want to write, it's now let's call it like first come, first served, and that's I'm mentioning that very lightly, okay? So what do I mean by that? So they decided everyone who's running the Google server in their home, okay, they to be able to earn the right to write on the Google Doc at this point in time, we want you to have like we want you to solve some sort of a puzzle. Okay, what do I mean by that? Let's say we decide to put like a mathematical equation, and we decide everyone who's running the servers will solve this mathematical equation first, right? Let's say x plus x squared plus y squared equals to, you know, the normal algebra. Let's just say like a mathematical equation. Okay, so they were like, okay, the first person who will be able to solve this puzzle will earn the right at that moment in time to be able to edit this Google Doc. Okay, that's what we call proof of work, right? So proof of work mostly, it's very prevalent in the Bitcoin sort of a structure, right? So how does this work? Remember, we've talked about the Google servers, right? So it translates to blockchain as the miners. That's why we call them miners and not validators. But I don't want to mention like a lot of names right now, but let's just call the Google servers. If the Google servers were working in Bitcoin, right? So they solve a puzzle. And by this puzzle, I'll show you guys what I mean by puzzle so that it doesn't look very abstract. Okay, so they solve a puzzle, and the very first miner to be able to solve this puzzle earns the right to like mine the next Bitcoin. Okay, that's how miners work. So when you hear people saying that they've set up mining farms, they've set up this, they've set up that, okay, that's what they mean, right? But now there's an issue. After this community decided to do so, and then it was working, some of the members were very disgruntled, and they brought this issue to the community, and they're like, okay, I'm running let's say a very light Google server on my phone, but I have this friend of mine who has several servers, which is still running the Google server, right? But now, when we're talking about solving this mathematical puzzle so that I can be able to edit in our public Google Doc, my phone is inferior in terms of computation. Because remember, it's not you as a person who is solving this mathematical puzzle, it's now your server. Okay? And then once it hits, and then it will notify you, ping, you're the next person to add to the Google Doc, and then you add whatever you wanted to add. Okay. But now imagine I have, let's say we are solving, let's say 50 times 100. Okay. Remember, let's say, or a very difficult mathematical puzzle, which needs a lot of computation. Okay. So this guy who has several servers in his home, and me, I'm running like a lighter Google server using my phone. By the time I'll be able to get the next mathematical equation and solve it and get the right to input what I want to input in my Google Doc, you see, he has the power, or he has he's more superior in terms of computational power, right? So, and it's still the same even when you look at Bitcoin, because when you decide to the reason why people have mining farms, it's because they know that with each halving, it becomes more and more difficult to be able to solve the puzzles, which are incremented in complexity, so that I can be able to mine the next Bitcoin. Okay, so you need to add more and more computation, and not everyone has the financial capability to be able to match to be able to match what? To be able to match these mining farms. I mean, if it was when Bitcoin was starting, let's say like around 2010, etc., you could be able to really mine a really good Bitcoin with your phone. But right now, by the time you even get to like 0.0001, it will take a long while, right? So yeah, back to our community, they were like, no, I'm trying to be able to compete with someone who has several servers in their home, and me, I'm only running with a phone. So they went back to the drawing board, and they're like, okay, how can we be able to sort of equalize everyone in a certain level so that anyone can be able to edit at any time when their time comes? Okay. That's why we introduced now the concept of proof of stake. That's where actually proof of stake came in, because people were like, proof of work, first of all, it's using a lot of energy, because the more farms you have to add, the more miners you have to have, you're consuming a lot of energy also, right? Electricity, etc. So there were also concerns about pollution and all these other things. So the team went back to the drawing board and are like, how can we be able to reduce the energy consumption and still have the same consensus algorithm whereby everyone will be, it's sort of a fair system, right? Because if I was to come in and say, okay, you'll be the next one who will add in the Google Doc, of course, there will be a lot of questions like, why did you choose this person over me? But with such a system where it's now the first person who will solve the equation will win, right? You see, there's not a lot of, because it's a fair system, there's no one who chose personally that this is the next person who will edit the Google Doc, okay? So now they decided to come up with proof of stake as a way to solve this problem that we had right now, this challenge. And so what exactly is proof of stake? First of all, they told everyone, we want you to stake. By staking, I mean, let's say we want you to sacrifice, let's say each person will sacrifice, let's say $20, right? So if you're going to run a server, I want you to sacrifice $20 and you lock it in the community treasury, okay? So once you do so, everyone has everyone has been able to give out the $20 in the community treasury, and they've locked it, meaning it's not like they can be able to access it, right? They've just locked it, what we call staking in blockchain terms, okay? So once we've locked it, it's now random. Okay, so this system will just randomly pick the next person who is going to edit in the Google Doc. So it's not now whoever solves the equation first is now earns the editing rights to our Google Doc. It's a random, I'm forgetting the English term for it. It's like a random thing. right? It's like a random gamble, okay? So anyone can be able to add at any point in time. So that helps even the person who is running our Google server on the phone, they can still have the editing rights, the same as the person who's running the server farms, because it's not about computation. I hope we're flowing along, right? So we started first with the first problem. We want to hold our own community servers, and that's where we introduced the first principle, whereby we have nodes. And I'll show you guys how these nodes communicate, okay? So we have our nodes, which is the first principle in blockchain, right? Coming in, and people can come in, and provided you have the hardware requirement, you can be able to run our own node, run your own node, okay? Challenge which they had, which introduced the next, why we have principles. For example, if you want to like mine the next block in blockchain, there's some certain rules, first of all, and also there's like an algorithm which will randomly pick people. So that's what that's how it worked in blockchain, right? We started with like proof of work, and then people noticed that it was unfair, okay? But we bear that in mind, that even though we have the proof of stake algorithm, which is currently working right now, these are the two major ones, because we still have a lot of other smaller ones like delegated proof of stake, etc. You can go check them out, but these are the two main, like you can call them like the two foundations of the consensus models, right? But now let's look at proof of stake, especially in how, example, the Ethereum, the validators work, right? Because remember, in Bitcoin, I've called the nodes, and of which by nodes, I mean the Google servers, right? I've called them miners because they're mining. But when you come to now the Ethereum ecosystem, they're now called validators, okay? So now when you check the way the validators work right now, we have like a minimum amount to lock, right, to stake, which is $20 for us. But then there's an allowance that if you want to add more, example, if I have the financial muscle, I'm like, I want to add, let's say 100, I want to lock $100 in the community treasury, okay? Now, the more you lock into the system, it's like you're prioritized. So it will still do the algorithm, the model will still randomly pick someone who will edit the Google Doc, but then we have an allowance for someone who has invested, let's say, $1,000. I mean, they've invested like $980 more than me, right? So they'll have the ability to be prioritized. So you'll find that they'll still process more transactions, and um, than me. Question: why the hell would I invest, let's say, $1,000, and I can still do 20, like the bare minimum, and I can't, like, I'll still run the nodes, right? Example, and remember, even though we're running our Google servers, we're still using our own resources, because I have to pay for electricity. I have to ensure that the internet is super fast. So I have to pay for like a premium package of internet, all these things. And you can't just tell me this out of the goodness of our hearts that we've decided to run the servers, knowing that it's going to cost us money. Okay. So with that in mind, it was now introduced something we call game theory. Okay. It's like an incentivization method. So someone would ask, why the hell would someone stake more? Why the hell would someone stake more than me? And we're still doing the same thing, and it's not like we're getting rewarded. Okay. So that brings the concept of game theory, whereby we're incentivizing people for the good of the community, and also to ensure that they are honest. What do I mean by that? So we have these Google servers, right? So our community decides that every person who writes an entry into the Google Doc, they earn some sort of money. Okay, so every entry that you add in the Google Doc, you earn some sort of cash, right? So you can see, with that incentivization model in mind, because when we come back to blockchain, every person who's running a node, remember we said in mining, when you solve the complex, when you solve the puzzle, and then you earn the rights to mine the next Bitcoin, you earn it, right? So how does the same proof of stake work in Ethereum? So when I lock more and I process the transactions which are coming in and I add them to the global state of Ethereum, all um, this money that people are paying for like gas fees, etc., they go that system in place. So it's still not fair in 100%, but when you compare to like the proof of work, at least it's not that bad, right? If I can say so. But now, what you can see that is prevalent in these current principles is the trade-off is some sort of muscle is needed. In proof of work, computational muscle is needed. In proof of stake, financial muscle is needed. Because you can lock, like, let's say, if I recall, it's like around 30 ETH, 30 ether, right? You can, that is like the minimum amount. But if you have more, you can lock more. And then now you'll be prioritized in terms of mining, processing the transactions, and adding the next block. Okay. So, but back to here, they've they've already solved the problem where they don't know who will start editing the Google Doc first. Okay, that's where consensus methods come. By the way, I'm not able to see if you guys have questions. So just in case you guys have any questions, please feel free to. Okay, let me see. Okay, so Mary Jane is saying you don't understand anything. I think, Sarah, is there a way we can like give her the mic so that I can figure out where we lost her and also get to know, is it like the first time you're hearing of blockchain, or maybe I think what do you think? Should I like continue? I don't want to leave anyone behind.
Yes, you can unmute.
Okay, so yeah, she can unmute her mic so that I can be able to know where we lost her. Ah, it's your first time. Okay, so it's your first time learning of blockchain, right? So I'll be able to connect. Right now we're like talking about the analogy, so it will look very abstract, but I have some illustrations which will help you connect the details to what blockchain is exactly. I have like 2 illustrations, so don't worry. And in the event you still don't understand, just hit me up on Telegram. I'll try to figure out where you are at, and then I can be able to like know how best to help. Is that okay with you? Okay, awesome. Let's continue. Yeah, so we were about consensus, okay? So we've done proof of work, proof of stake. Let's continue to the next challenge. Yeah, so another challenge this community encountered is that obviously the current model that we have right now, we have to operate in good faith in that everyone has good intentions. But realistically, we can't say everyone is operating the Google servers out of the goodness of their heart. You know, remember what we talked about. What if someone wants to like add details which are not needed in the Google Doc? What if someone wants to operate like a Google server so that they can be able to have access to people's data, to people Google's photos, and then they use some sensitive photos of you and then they sort of blackmail you? We have so many bad actors in the ecosystem, right? And realistically, when you even designing any sort of system, you have to always remember that there will always be bad actors in play. So blockchain was also it also was also done to be like it was also designed with that in mind also, right? So how can we ensure, since now we don't have an admin who when you're running a server and you're doing very bad things behind the scenes that they can kick you out, it's a very consensus mechanism. How do we ensure that bad actors do not overtake the system and then they encrypt everything and then they tell you we have to pay in crypto, or you have to pay in something so that we unlock your files, right? So this is where something we call Byzantine fault tolerance comes in. But you don't have to like remember Byzantine fault tolerance, etc. But to give you guys a quick a quick like history of where the term even Byzantine fault tolerance came from. It's an old military Byzantine problem. I think it was called like a Byzantine problem or something, right? Whereby imagine you're now a general and you're planning like a war strategy against your adversary on the other end of the war zone, right? But now you're not entirely sure if the military, if the generals, your fellow generals, you're not entirely sure if they are traitors, right? Because we've seen it so much in a scenario where you're planning something, and then we have people who are like moles and in your system, whereby their work is to transmit all the strategies that you have to the other end of the party, right? So when you go check it out in terms of history, that's where the Byzantine problem came from. If you're a general, how are you able to create a system which is proof, despite the fact that some of your generals might be bad actors? Okay, so what do I mean by this Byzantine fault tolerance? So when we look at it in blockchain, they decided that of course, let's say that okay, when we say like a blockchain has like a two-third BFT, what do we mean? The way blockchain is designed, right? Everyone has a copy of everything. Okay, if it's that Google Doc, everyone has a copy of it, right? So if you decide on your end that you want to like do something dirty, and then we have the rest of these servers, and they all communicate in a way that we call peer-to-peer, but I'll talk about peer-to-peer properly. But when I talk about peer-to-peer, imagine like a radio station, right? So you see the way a radio, if everyone decides to like have like a radio station in their own house, and then if a neighbor wants to broadcast something like an announcement, they broadcast it, and then it is received by all these other stations in real time, right? That's the same thing. So when someone is adding something in the Google Doc, it is broadcasted to everyone, because remember, everyone has a copy of this Google Doc, okay, in their own system. So everyone is broadcasted to it, right? So imagine you had made a commitment to someone that I'll share, let's say I'll give you services tomorrow and then you pay me back. And then this person comes later on and starts saying, no, I didn't say such a thing. I did not say I'll pay you back. We said it would be free. And then on their end, they decide to like change like the Google Doc on their end that we said it's free. My contract says it's free on my end, right? But remember, everyone has this Google Doc. Okay, so first of all, they'll come and compare. Okay, you're saying at this point in time, let's say yesterday, you're saying yesterday that your contract said that I was supposed to work for free, right? But on my end, my contract is saying that my version of the Google Doc is saying that at this and this point in time, we decided that you will pay me, let's say $20, and then I provide the service to you, right? And remember, it's not like we're the two of us who are only holding this. We are only running these servers, and it's not like the two of us who only have like this copy of the Google Doc. Okay. We'll still go to the other peers as well, and then we're like, okay, what does your version say? My version says this. What does your version say? My version says this. So if like two-thirds of these people agree in consensus that at this and this point in time that everyone says you have to pay, there's nothing this person can do, because and that's also brings this principle in blockchain where we call it immutability, because and of course I'll show you guys now illustrations, right? Because right now we're talking in higher level, because if I wanted to change that specific detail, right, I would have to go to that person, I've changed my copy, right? I would have to like go to each and every neighbor who is running like a server and ask them, or maybe bribe them or something, that they should be able to change they should change that detail at this and this point in time. And remember, it's already set in stone, like it was already added to the Google Doc, right? So even when you decide to come and change it, because we have the history, just like how you can see in Google Doc when somebody changed this, somebody did that, you can see like a history, right? So we go back to the history and they're like, but our versions are saying different things. Okay, and so that for you to be able to successfully change each and every person's like a copy, and are like, okay, just please help me out and just say it's free. What if we have a community of 1,000 members? You see, that is like very difficult. By the time you're entering into every person's home and telling them, please change this detail for me, right? So that's something we call Byzantine fault tolerance. So even when you check the way blockchain is designed, it's designed in a way to sort of tolerate bad actors in the ecosystem. So if someone sends a transaction to another person and they're trying to like let's say delete that transaction, that would mean that they will have to go to all nodes which are running in that ecosystem and change all these details, right? But that is impossible. So that's why we say blockchain is immutable. Once something is added to the Google Doc, it's not removed. Okay, so I want you to imagine a scenario. Of course, I know in our Google Docs we like clear out, but once something is added to the blockchain, it can't be removed. Once something is stored in blockchain, it can't be removed. That's the whole concept of immutability, and it was built that way, thinking about something like bad actors of the ecosystem. And so when we talk about Byzantine fault tolerance, per se, what we're saying, it's your blockchain's ability to be able to tolerate bad people in the ecosystem but still run. Okay, I hope I've been able to like help you guys see. So when you see Byzantine, just remember, in our community, not everyone has every good intention. So how can we still manage Google in a decentralized way and still not ensure bad actors don't take over the ecosystem? Okay. All right. So where we've come so far, to give you guys, remember we started Google shutdown, and then we decided to each person in each home will run a server, and then we have the nodes, right? Now the nodes, they work in a peer-to-peer system. By peer-to-peer system, I mean they sort of gossip with each other. You know the way gossip works, right? So if I get this, I submit it to all the peers in the network. It's not like we have like an admin or something who will like, let's say, push a notification to all the servers or anything. They sort of transmit the information in itself. That's why you see terminologies like broadcasting, gossip protocol, the peer-to-peer P2P system, etc. But essentially it's that, right? So we started with our servers, we've made our nodes, okay? Then we had our public ledger, we have our public Google Doc, okay? But we had to decide who will start editing what, right? And to be able to get to that level, first of all, we had to set consensus rules whereby we know you can't add something to the Google Doc if it's, let's say, it's spammy, or you can't decide to add like an ingredient list that you are going, let's say, to the market, or you can't add any information. You see all those rules that we're setting, that's what we call consensus rules, right? And then we went back to the consensus model, whereby we decided, first of all, we would start with a proof of work system, whereby every person would compete to solve an equation, and the first one to solve it will earn the right to add to the Google Doc, okay? But then it brought a lot of issues, because what if I'm running the server on my phone and someone has a lot of servers and they're getting, let's say, most of the equations right? So now they are the ones who are editing the Google Doc a lot, okay? That's where we went to proof of stake, whereby we decided everyone will lock some certain amount, and then the system will decide randomly, okay? But then also the community members were like, so why should I even run a Google server in the first place? I mean, the previous Google, I didn't have to do anything. I didn't have to like, and everything was like free, right? So that's why we introduced the game theory a system in mind, which applies also in blockchain, whereby anyone who is running these servers, because they're running hardware in their homes, right? They still need to pay for electricity, they need to pay for this, they need to ensure that the system is always up, there's like minimal downtime. So we decided to bring the system where everyone who's running a node, once you like edit, you get something in return, right? So and then afterwards, we decided, how can we ensure that even if we might have people who have bad intent tolerance mechanisms, okay? So I hope up to there we've been able to, oh, my internet is unstable. Let me just see. Okay. Okay, yeah, I hope guys can still. hear me, right? Now, we got to another issue. Okay, so remember, we're running this Google servers, and obviously we've opened up services like Google Photos, Google Drive, Gmail, etc. So I want to use Google Photos, okay? But remember, we've said every person has like a copy of all these things, right? In their own, because they're essentially offering the space whereby I can be able to upload my Google Photos, right? So if I don't want anyone to see, I don't want anyone to see my photos, right? But I still want to use the Google, I still want to upload them to photos and all Google Drive, etc. So what do we do about that? And ensure the system is still open in a way that if I've uploaded something, it will still be recorded in our global doc that at least at this point, this one let's say uploaded certain things, right? But I don't want anyone to know how I'm using my photos or how I'm using my drive, etc. That's where the whole aspect of the privacy in terms of blockchain comes in. Okay, so we have something we call hashing. What do we mean hashing? Let's say we sort of encrypt my Google Photos, like how you see in your phone where you can like input a password so that no one can access like your Google Photos without having to like know your password. I mean, it's not exactly hashing like, but I'll talk about. I want you guys to have the picture, right? So, what does hashing mean? I want you to think of hashing as, let's say, we are blending some fruit. Okay, so my photos are now this. Let's say I want to blend what I want to like have a smoothie, having like bananas, some milk, etc., whatever, and the blender is the one that is giving us the juice, right? So my photos will be like the raw ingredients, my bananas. If I want to add like pineapple, some sugar, etc. That is now my photos, right? The blender in itself, it's like the algorithm which will output something, right? What will be the output of this? It will have like some smoothie, right? So the smoothie will be like an encryption, or sometimes we call it like a digital fingerprint or something. But let's say it's like an encryption which represents your photos, right? And this encryption, like a code, let's call it a unique code. Okay, so once I upload my photos, etc., there's a unique code which is representing my photos. That unique code is which will be stored in the Google Doc. Okay, and the way hashing works is just as how once I have made my smoothie, I can't reverse engineer like my smoothie to the raw ingredients which I made. It's the same thing. Once you encounter this like unique code, it's difficult to like reverse engineer, right? It's a one-way thing. So someone can't like take you if you've seen, okay, Cyndie uploaded the unique code to photos, right? Or something, okay? They can't take that and try to reverse engineer and get your photos. That's how hashing works, okay? It's one way. And also one more thing you need to know, which is very important, is just like how if I use one banana, one glass of milk, and let's say what, a pint of sugar, right? I'll have a specific output. If I always do the same thing, if I also go again and take one banana, one pint of milk, one pint of sugar, I will always have the same thing. I won't wake up one day and I do the same and I get a different smoothie, right? So we call that deterministic. Every time someone uploads the same photos, they'll still get the same unique code. It doesn't change. The only time it changes is that if I decide to add, let's say, more photos or remove some, that's where the unique code will change, right? That's what we call deterministic. So when you remember hashing, just remember the fruits and the smoothie thing, right? So we have our input, which is the fruits, and then we have our blender, which is like the algorithm. Let me just call it like the mathematical algorithm, which it takes the input and then the output, the smoothie, will be like the hash of whatever you inputted, right? I'll show you guys in real time what I talk about. So they were able to solve the concept of privacy, meaning I can be able to use my Google Photos very well because I know in the Google Doc, it will just be updated that at this and this time, I added some photos to my Google Photos, but no one will be able to access that. That's what, when we talk about privacy, that's something which we talk about, right? So you have the autonomy to be able to use the services, but you still have this privacy. Okay, remembering that fact that the public doc is very public, like our Google Doc is very public. Okay, so I hope you've gotten that. So, but just a recap again, we started with nodes, and then we went to consensus. Let me see if I've forgotten anything. Yeah, we started with nodes, and then we went to consensus, and then we handled the Byzantine fault tolerance, and then we incorporated the game theory incentivization to help people be able to like run things in the blockchain. And then now we've talked about privacy, which is one example of privacy is hashing, right? And we've also talked about the concept of immutability in blockchain. Okay. All right. So now the system is working very well. I have my Google services, but now what if someone decides to like upload 10 terabytes because they've realized, okay, maybe this is like free storage, right? You know, in Google, obviously, when you exhaust like the how many gigabytes do they give you? Let's say they give you like 2 gigabytes for free, right? Using Google. But when we want to store more things on Google and you don't want to pay for it, you have to like remove you have to delete some of the things in your storage, right? Just like how in our phones, you'll have to pay for like cloud, or you have to pay for like the SS, is it called the SSD, or what is it called? That small thing that you input to get more storage, right? So how does this work in blockchain essentially? Because remember, it's not like you can deny someone service, right? If someone wants to upload 10 terabytes of storage, they'll want to upload. It's not like we can go there and start saying, oh, you're using a lot of space, get out or something, right? Remember, it's a very equal system, okay? So how do we counter such scenarios to ensure that everyone has a chance to be able to use the Google Drive? Remember, each node is providing space, right? Remember, we started like, let's say each person will come with like 2 terabytes of storage. So when we pull all this storage together, it can be used up a lot, right? Because someone can decide to like upload 10 terabytes of cat videos. What are you going to do? It's not like you're going to tell them, no, please, or something, right? This is the one now the concept of gas fees came in. Okay, it's like a premium. Remember, we talked about the incentive. We talked about our people who are running the Google servers. They need a way to earn, otherwise they will not be motivated to. They will not be motivated to do what? To run the Google servers. Okay, but where are we going to get the money to pay these guys from? Right. So now on the user's end, everyone who's using this blockchain, because some people they may decide not to run the Google servers, but they will still want to access Google services, right? So this is where you pay gas fees, something we call gas fees. Okay, so this avoids the scenario where someone can, in blockchain terms, someone can write up a program which does not break. You know that program that will run, it will run. What's this English term? It will run and run and run without stopping, right? Let's say you've written like a program and you've forgotten to add like a break so that it can be able to break, right? It can run and run and run and run to infinity, but still our resources are not infinite. Our resources are very finite, right? So you'll end up using all the resources. Just like how in your computer, sometimes there's some programs you can run and they can use up all your RAM and your computer starts hanging, etc, etc. It's also, let's just talk about it. You can say it as the same thing, okay? So anything that you want to do to the blockchain, you pay some sort of fee for it, okay? And this helps. And the more you store in blockchain, actually, storing data in blockchain is the most expensive thing. So that's why you'll find people don't store a lot of things in blockchain, right? Because it's very expensive. Because the more you store, the more you earn. It's not like a standardized fee or something, okay? The more you store, the more you earn. And also, if I want my, let's say, if I want like, if I want, let's say, to add a certain detail to my Google Doc, and I want it to be very fast, right? I can pay more gas fees so that my 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 message, which I want to add to our public Google Doc, can be prioritized because, of course, we are going to first. It's a premium package, right? Of course, the person who pays more is prioritized first. Okay, but the whole concept of gas fees, it's like you're paying for the services, and to avoid scenarios where people will sort of do DDO, DDoS. What's the denial of okay, I've forgotten the term, but to avoid scenarios where people will want to use the services of the blockchain infinitely for free. Okay, so gas fees is like you're paying to use for blockchain, and these gas fees are what goes to the people who are running the nodes, right? So it's a very self-sufficient system. Okay, yeah. Let me see if there are any questions so far. Yes, DDoS. Is it like distributed denial of service? Okay, all right. Awesome. So yeah, finally, everything is running very well, but people realize, okay, now directly writing to the Google Doc is very slow, okay? Because you have to like wait until until you like a random server is assigned your message to add it to the Google Docs, okay? So what system was introduced? Now, they introduced a P2P system we call Gmail, but in hindsight, I should have written it like a roll-up system. I'll talk about it, okay? So we now have Gmail, okay? So we came up with a system where instead of me writing directly to the Google Doc and waiting in like a waiting list, let's say there's like a waiting list, right? Whereby you're waiting for your message to be included to the Google Doc. We decide, but we have this system called Gmail. Let's just use the principles behind Gmail, right? So any message that I want to do like a contract, let's say any message that I want to do, like let's say I want to say I sent money to this person, I sent this to this person, I did this, you send like an email, okay? And then now Gmail in itself, it will bundle up all of these messages and then submit them to now the Google Doc like after the nodes they've processed, they've let's say they've systemicized every person's message, right? So the nodes they've gotten the rewards, they've processed all the emails which are there, and then now it's sent like a bundle directly to the Google Doc. So instead of directly editing the Google Doc, use Gmail. Okay, so that's the concept of layer twos. When you hear like layer twos, roll ups, etc., it's the same thing because you're like, okay, Ethereum, it reached a point, it's very slow, and the gas fees are very high because once the network is very congested, gas fees go high because people will now pay more so that the transaction can be prioritized. Okay, so people are like, okay, what are we going to do about this? How can we make this system faster? So they decided to come up with the concept of layer twos. So layer twos, the work is to process all these transactions on behalf of Ethereum. And then just like how Ethereum, we can call it like our public Google Doc and all the layer twos, like our Gmail service, okay? Every person who's like submitting a transaction to somewhere, they will like process all these transactions. They will do this, they will do that. And then afterwards, they bundle them up after everything has been settled, that we've confirmed, like you haven't, like, let's say, written a message which was not as part of the proof, and maybe you have done this, you have done that, everything is okay. They bundle up all these messages and send them at once to the public, the Google Doc. So the Google Doc is receiving all these messages which are like put in order, okay, as a bundle. So there's no more directly editing to the Google Doc. We are now using Gmail, okay? So it's like a roll-up service. I want you to see email as a roll-up service. So when you see layer twos, most of the time when we talk about the concept of layer twos, their work is to process transactions on behalf of Ethereum. And then now they bundle up. That's what we call roll-up. They like roll them up, like they bundle up all these transactions, they send them as a bundle to Ethereum, which is like a public Google Doc, and then Ethereum just settles. It's like just to make it's like now the work of Ethereum is just to have all these transactions in order. But in processing, layer twos, that's the work that they do. So layer twos like Starknet, and also like tomorrow I'll give you guys a quick overview of what type of layer twos there are. So before we like enter deeply into Starknet, so and by what type of layer twos I mean, how do all these layer twos process these transactions differently? Okay. All right, so that's how Gmail works. So people now not directly editing the Google Doc, they are using email, right? Okay. So yeah, so you can, I also wanted to like add a bit more details. We can still use our Gmail scenario, okay? So I want you to see Gmail as a wallet also, okay? So what if I want to send money to my neighbor John? What sort of system? And we want to use it using our Google service, okay? What sort of system will we have? So we'll have something we call a wallet, okay? Let's say like it's like a placeholder for your assets. Okay, so I'll open, just like how you normally send an email address to someone, I'll open my Gmail, right? And something, when we talk about wallets, something which I really I want you guys to see is something we call private public key cryptography. I'll talk about it, okay? Just like how, example, anyone can have your email address, right? But by the time you're creating your email address, you have your account and you have the password, which is responsible for accessing your Gmail account, okay? So I can share my email address very freely here, but one thing I can share is access to my Gmail address, which is like my Gmail account, which is protected by what? By a password. How does that translate to blockchain? Now, remember I was talking about public private key, okay? So when you hear people talking about send me your wallet address, send me your wallet address is normally like a short, let's say like a short form of your public key. Okay. So when someone says that I want you to send, I want you to send you some tokens, please send me your wallet address. It's like a short form of your public key. Okay. So in cryptography, we call it a public key. Like just like how we're talking about our email address. So you can share it with anyone. Okay. It's very public. But now she types John's email address. That's also John's wallet address, the public key that I was talking about, right? And then I tap a message, send 5 tokens to John, right? That's like creating a transaction. Okay. I want to send 5 tokens to this public address. Okay. And then she clicks send. But before she sends, to confirm that let's say it's Cyndie who is actually sending this email, right? Not someone who's impersonating her, someone who's claiming to be Cyndie, because this is money. Okay, just like how you will send money online, obviously you'll need to input some sort of a password or a PIN number, etc. So before she sends, she'll input her password. What does that translate to in blockchain? Remember, I have my password. So just like how I have my public key, which I can share, I have my private key, which I have to keep it private because it's like a access to my account. Okay, that's why we always say, not your keys, not your coins. The private key, you always have to keep it very safe, just like how you'll keep your password safe. And the reason is because based on how the principles, the foundational, when you check like the system design of how blockchain was designed, the wallets, because of all the cryptographical techniques which were added to blockchain, that's why we have our wallets which have public keys and private keys, which it's like just you input your password so that you're able to send the money successfully, right? So to be able to confirm that it's actually Cyndie, not someone who's like impersonating me, who's saying send tokens to John, I sign this transaction with my private key, right? Just like how when you send like money, you will input your PIN, right? Even when you're using like your bank, etc., you'll input your PIN, okay? It's the same thing. So I'll sign it to confirm that it's truly me, because remember, I have my private key, I have my password, right? And then Gmail will send this mail to our community servers. So this is what I was talking about, transaction. This transaction will be broadcasted to our peer-to-peer network made of the Google servers, okay? And then if it's proof of stake, one person is chosen randomly to do what? To process this transaction, okay? And remember, when I was sending this, I've already like added gas fees there. So when they process this transaction, they get that gas fee and then they complete it, right? And then it's added to the bundle, which Gmail will eventually send what? Send all, let's say like when it hits like a cap of 1,000 emails and they're all processed, they bundle it up and then they send it to Ethereum. Okay. Yeah. So John wakes up and then they receive an email. You've received 5 tokens from Cyndie. So their balance is updated. If they had 0, they had 5. Okay, so when we talk about public key, private key, you can just look out. It's like I have a public email address, but I have my password, which when anyone is able to encounter this password, they can have access to my account and there's nothing I can do. So it's the same with how wallets work. So once a person has access to your private key, essentially they have access to your account, because any sort of transaction, whether it is like removing money from your account, they'll sign using this very same public key, which was assigned to only you. Okay, so it's the same thing. All right, let me pause, see if we have any questions. Okay. So is there any questions so far? Are we good? Let me just check. Okay, awesome. Yeah. So we're now at the final bit. Let me see. Okay. We're now at the final bit of this part 1. Okay. So obviously, when we started, we had we had rules which we entered into like a community hall, and we decided we have these rules. No one is to update this. No one is to do this. If something is valid, we can ah yeah, when airdrop, we'll tell you guys, please, when we'll give you guys an airdrop. So what was I talking about? Yeah, so we have like a community hall where we sit down and discuss moving forward, what sort of rules are we going to put, right? But now, because things change along the way, obviously we'll need to be revising over and over again the rules of conduct that we set to be able to use this service, okay? So now that means, let's say every week or every 2 weeks, someone they have to keep going to the town hall so that they can be able to like change something. If let's say the formatting of the document is different, they want to do this, they want to do that, no one has the time to keep on doing that, right? So that's why we introduced the concept of smart contracts. Okay, so it's like it's like a set of rules, right, that you write, a set of rules that you write based on, let's say, the program that you're writing. And if this rule, the condition is, okay, let me look for let's say for a smart contract, we say, if what? Let me just look for a very simple, let's say we write like a contract, right? And then we're like, okay, if this person spams the group 5 times, their network is kicked out. Let me just give that as an example. That's like a rule we've set in smart contracts, right? So we don't have to keep on coming because someone has, let's say, someone has broken the rules five times. So we now have to come as a community and vote and say, okay, should we vote him out? Should we do this? Right? That's a lot of work. So we now have these rules which we've written in a smart contract. Okay. So if this person does the breaks the rule 5 times, this smart contract will be triggered, okay, and then it will kick the person out. Okay, so we avoid the scenario where this person has done these things 5 times. We now have to look for each other as a community. We get to the community hall, we start voting. Do we kick him out? Do we give him like a warning letter? Do we do this? So that's the whole logic behind like smart contracts. Okay, it's like you're writing. It executes what you want, the sort of result you want, based on the rules that you set in the smart contract. Of course, that is a higher level overview of how these things work. They like predefine the rules beforehand, right? Like if you break the rules 5 times, you're kicked out. So now, instead of looking for each other at the community town hall so that we can be able to vote, do we kick this person out? And the bad actor has decided to like break the rules 5 times, this smart contract will be triggered, and then it will kick him out on behalf of the people. So the people don't have to keep on the rules that they set beforehand. Okay. And yeah, with that, I think we can connect Google to blockchain, and then I'll show you guys something before we get to the next part, which is ZK. Okay. So first of all, the community decided to host Google by themselves, and the blockchain principle behind that is that's why we have nodes, okay? So that when you hear people say with blockchain we want to overcome like centralized authorities, we want to do this decentralization, because that's something we talk about a lot. Decentralization, what does that mean? It means it's the communities which are managing like these services, like the nodes, right? So it's not one person, they're managing the blockchain in itself as a community, okay? And then, yeah, we need to agree, because there's no admin who can point out and say, you come next, you go after, etc., like that. We need to collectively agree who edits the Google Doc. That's why we talked about the consensus rules, the rules which you're talking about, like this transaction will be kicked out, will not be added to the Google Doc if it's spammy. Those are some of the rules. And then the means of getting into the means of agreement on how exactly we'll edit. That's now the consensus algorithms. And by consensus, I meant proof of work, proof of stake. Okay, that's the next principle of blockchain, right? What if someone is malicious? Because you also need to think about that. We have now the Byzantine fault tolerance mechanisms, the different mechanisms, right? So you always hear people say, like, this blockchain is designed with like 2/3 BFT or something. That's like, they just want to show you that the system will still be up despite people who will try to like perform bad things on the blockchain, okay? I want to keep a history of all the edits, okay? So like what we talked about, immutability, the fact that once something is entered in blockchain, it can't be reversed. It would be very difficult to like remove what you've edited, because remember, all these nodes, they have a copy. At that certain point in time, they have, each and every person has a copy of the Google Doc. So you have to go to everyone and convince them to remove it. And that by removing it, you have to go to everyone so that they all reach a consensus that moving forward, this is the state that we have of our Google Doc, where this person was supposed to work for free instead of paying, okay? And that becomes very difficult, because how are you going to convince all these other peers to be able to change this? And each person has a record. That's why we always say blockchain is immutable, okay? Privacy. I want privacy for my photos. That's why the concept of hashing come in. So when you interact with the blockchain more, you'll see like transaction hashes, you'll see blockchain the block hashes, several types of hashes, okay? But it's just for privacy. And by talking about hashing, I'll show you guys. Remember the concept that we had for our fruit, blender, and juice, okay? You can blend the fruits to the smoothie, but you can't turn the smoothie back to the fruits, okay? That's the same way with how hashing works. It's one way. And also, provided you're providing the same ingredients to the blender, you will always have the same output. So it's deterministic in that way. Provided you're providing the same input, you'll always have the same output, okay? And then to promote fairness, so that we don't have people who are trying to like misuse the resources by the blockchain, we introduce the concept of gas fees. And this gas fees, remember, it goes to the people who are maintaining the nodes, which are processing all these transactions, okay? So we have gas fees. And then to be able to write like a digital form of rules, which will be triggered every time something happens, we now have the concept of smart contract, okay? So let me just pause there first. Okay. I don't know if anyone has any questions, but let me just, okay. Before we go there, I wanted to show you guys quickly. Why is this? Okay. I hope you guys can like see. This is it's a very good like real world type of example of how a blockchain looks like, okay? So remember what we were talking about, the concept of hashing, okay? Right now, the hash of this empty space, the space is like empty, okay? So this is like the hash you said. And when you look at it, despite everything that I add, if I can just decide to like add so many things, let me just like do this. Wait, where's the mining? Despite doing this, you can see the like hash is changing, but the hash always has the same characters. If you can see, there's no point you can see like if I add like if I decide to add like an entire dictionary here or like an entire book, etc., the hash will always have the same characters. Okay, so behind the scenes we have this input, and then it is sent to the mathematical equation, which translates to this hash. Okay, so this is how hashes are generated in blockchain. Okay, so You see, right now it's empty. So we have like E3, B0. So every time it's empty, oh, I'm adding more things, sorry. Provided every time it's empty, this will always be the hash of this empty thing. There's no point in time you'll come back and you'll see like a different case, okay? And just to give you guys, this is like an example of the algorithm, let me call it like an algorithm, which is used to design this sort of hash, okay? So we have this SHA-256. It was actually used some time back. I think right now right now in Ethereum, we have like an hashing algorithm, which is called like Kechak, if I'm not wrong. Keccak. But again, I might be wrong, I've forgotten. But this is just like an example. It's a very simple hashing algorithm, okay? Provided the space is always empty, you'll always have this. So if I decide to add a dot, you can see it's changed. So if you change anything at this point where you've inputted your data, the hash will always be different. Okay, let me see. I hope how do I relate? Okay, I'll come back to that just a sec. Okay. Yeah, so that's a hash. Okay. So when we're talking about a blockchain, what makes blockchain now this is like now deep into the remember there's a time when I was talking about when the validator processes and adds the next block, they'll be able to like get some gas fees, okay? So in blockchain, how exactly do we, let's say, add information to the public ledger, okay? It's through these blocks, all right? So we have this first block in our chain of blocks. That's why we call it blockchain, okay? So before I even talk about nonce, so as you can see, the data is like, the data is nothing, and this is the hash. So this is like a proof of work. You remember when I was talking about the proof of work system, right? This is like a proof of work system. That's why we have this mine here, okay? So we have this first block in our blockchain. So if you remember, I talked about in proof of work, right? People solve like a puzzle, okay? So here's an example of a puzzle which I talk about, okay? So you see this nonce here. We have then this nonce is used differently in blockchain, okay? This is like a proof of work nonce. What do I mean with that? This is in simple terms, this is like the puzzle. This is the puzzle which these computers are looking to solve so that they can be able to mine the next block. How do you know that you've been able to do what? You've gotten the right number. Nonce is a number that is used once. Okay, I hope I haven't lost anyone there. So remember when I was talking about like the mathematical equation that you have to solve, like the puzzle, this is what I was talking about, right? So if someone is solving this puzzle, like let's say a miner, okay, they have to look for a number which the correct number will have the correct hash here. You see, like example, this hash has like 4 zeros, okay? So find like behind the scenes, let's say I've set a rule that the correct hash needs to have 4 zeros, okay? And so to be able to get this hash, I still have this data here, right? So example, let me put 3. Why does the block become red? Because remember, this nonce was when the data was like empty, okay? And it was able to satisfy the rules which we said that every hash which is a legitimate hash needs to have like 4 zeros, okay? So if I put 3, the block now becomes red because now it means, I mean, this hash, it still has created a hash of this data, but it doesn't solve the rules we set where the legitimate hash has to have 4 zeros, okay? So what do? We mine. As you can see, the nonce has changed, okay? So this nonce at this point of time, it's the puzzle. And by nonce, I mean, what the computer does, it starts from 0, okay? So it goes to like a example, it starts with 0, and then it says, okay, it doesn't solve the first hash, the four digits, 1, 2. So it goes that way, 3, 4, until it gets to that number, right? So the computer, like now my computer here, it had to start like counting from 0 until it got to 52,918. And then it realized, okay, this is the number which, so when it's applied to this hash, the hash has like what? 4 zeros. Okay, this is a concept. This is like now the proof of work nonce. It's the puzzle which you were talking about, which computers have to like solve it very quickly. Okay, so imagine now I'm having my phone, it has to start applying all these rules from zero, and someone has like a mining farm. Obviously, they'll be able to solve this equation very quickly, more than me. Okay, and you can see why this system is not working. Okay, but that's the whole concept of nonce. But also, we can talk about nonce in like a transactional way, in the sense that if I send like 3 transactions, okay, let's say I decide I send money to my mom first, and before it's processed, I send money to my aunt, I send money to my this other thing, okay? So before they're processed, there's a number which helps to order all these transactions. So if I sent my money to my mom first, that transaction will have like the nonce 0. If I sent money to John, it will have the nonce 1. If I sent money to Mary, it will have the nonce 2. And the reason why it's that way, it's because remember, by the time the transaction is like processing, they know they're processing your transaction, they first need to check, do you have the money to like, if I send 50, 50, 50, and maybe I have only like $20 in my account, but I've submitted the transactions, they'll still need to proof check and confirm that you have the you have like you have the what? You have the money which is needed, right? That's why that's why we have like the transactional nonce bit of it, where every transaction you add has its own number and it's incremented to avoid such scenarios where you're trying to send money twice to someone and you don't have the money. Okay, so nonce can be applied in proof of work. Nonce is like the puzzle which I was talking about, but when it comes to like the transactional bit of it, there's still another aspect of nonce. Okay, but back to our proof of work system, here it's like the puzzle which we're solving, so that we can be able to have like the four digits which help us know like the hash is okay. Okay, so let me just see. Okay. All right. Okay, thanks a lot. Okay, so now this is a block. Okay, so when you come and check like the blockchain in itself, this is now how blockchain looks like on a higher level overview. Okay, so we have the first block here. Remember, everything is like everything is blank. Okay, so we have the first block. This was the nonce, which was did this, and then we have this data here. Okay, so we have this previous. You can see like the previous is 0. This is what in our blockchain terms we call like a genesis block. Okay, there was no previous block in front of it. When we were talking about like the concept, so the way these blocks work is like and also the concept of immutability now in blockchain aspects. Okay, so we have this hash here, right, specific for this block 1. Okay, when we come to block 2, you'll see the previous hash which connects it to this first block. Okay, and then it has its own hash here because it has its own nonce. And then now when we come to block 3, it borrows it like connects the previous hash. So blocks essentially, it's like they're connecting backwards. Okay, they're connecting each other, they're connecting with each other backwards. So every block will always have the previous hash. And why is that important? It's because, let's say I've changed some data here. Okay, as you can see, I've changed the data here as 1. And now, oh, what have I done? Sorry. Yeah, let's say when this block was being created in blockchain by the node, let's say like the miner or the validator, let's say like our node, right? It created this block knowing the data here was empty, right? But then I come in and I decide, okay, so what if I say like there was some data inside, like 3? You can see all the blocks are now invalid because first of all, this hash, oh, no, don't go back. First of all, this hash has changed, right? And now you can check like it's picking up this hash over here, but now everything is like everything is not what is it called? Everything is now different, okay? Because now I have to come and mine here. But still, just because I've mined it, I still also need to come and mine here so that it's able to like change everything, okay? And I still have to come and mine here. I still have to come and mine here. I still have to come and mine here. So like so this is now the block's point of view, okay? So every time you want to change something, you have to now especially the far back, because remember here we're starting with the Genesis block, right? So imagine we now have 100,000 blocks, right? And we decided at this point in time, I have to do what? I have to come and change something here. You'll now have to go through all those other blocks and sort of recompute them, if I can say so. And that will take a lot of time. Okay, that's why we normally say blockchain is immutable, because now you have to now start come here and change everything. And imagine you have 100,000 blocks. Okay, these are just 5 blocks. Okay, but to reinforce that concept of immutability, where once something is stored in blockchain, it's difficult to like remove it, we now come to the distributed system, which I was talking about, right? Remember, let's assume this is our Google Doc, right? Remember, we said each person has a copy. Okay, so I have this peer. That's why we were saying peer to peer, right? So I have this person A who has this copy, right? And then I come to this person B who still has the same copy. As you can see, everything is the same. There's nothing like it's different, right? And then now I have this peer C who still has the same copy, okay? So if I come here and decide to change, and I just like how you were saying, I decide to change my Google, my part, like my Google Doc, okay? And then I come back and I start mining here, and then I start mining, and then I start mining, and then I come and start mining. The reason why they're red is because you can see, like, yes, it's picking up the right hash from here, but there's the nonce for this place, because so many things are changing. You still have to recompute it and get like a different nonce so that it can get the 4 zeros we were talking about. The rules we set, like a good hash has to have 4 zeros, right? That's why we're mining. So we mine here. Okay. And I'm like, yay, everything is green. But now let's come back here to this peer B and peer C. As you can see, the hash for my first block, right? It's changed because it's 73E. Okay. But when I come to my peer, it still has the previous copy, because it has like 157, 83B. Okay. When I get to the other peer, it still has 157, 83B. Okay. So now, if I want to change all the copies which are in the data, I'll still have to come down here and convince peer B to change it, right? So I'll have to come here and mine again, mine. So that, yay, we look together, right? But still, what if we have like 100 peers here? And remember what I was talking about, the Byzantine fault tolerance, okay? Because we'll come and see, so we have these 2 peers, peer A, peer B. Their Genesis block is saying that the hash of that block is 0073E, 0073E. But why our copies, it's showing different, right? And remember, the peers are many, okay? So with that in mind, we'll know these 2 are bad actors, so we kick them out of the network, okay? This is what I was talking about, like the designing your system in a way that you might still have bad actors in the system, but it's working because every peer has a copy. And not unless you now convince all people who are running nodes to come and change something that you want to change in the blockchain, and of which, remember, still, if we had 100,000 blocks and we have like 3 peers, that's now 300,000 blocks. You need to go back and change all these things, right? So it's like virtually impossible. That's why we say once something is stored in blockchain, it's stored in blockchain. Okay. Yeah. So this is like the distributed blockchain aspect of it. So before we get to ZK, do you guys have any question? Any question? Okay. So I think we can now go to like the next part 2. Yeah. So one other concept I wanted to introduce it will be like a good thing. It's like a preview of what we'll talk about tomorrow in terms of Starknet architecture. Okay. So introduction to ZK proofs. And the way we can handle this is, imagine you're going to the club, okay? And bouncer wants to know, are you over 18? Right? So in normal scenarios, what happens when we go to the club? So you'll have to produce like an ID, Okay, so what if you have a scenario where you've forgotten your ID at home? You're over 18 for sure, but you've forgotten your ID at home, right? So how are you going to prove that you're over 18 and you don't have that identification as a solid proof that you're exactly over 18, right? So how are you going to prove you're over 18 without an ID? Okay, so after having that challenge, we decided to open up ZK Club. Okay, so the way this system works is, imagine, let's say when you born, right? Each person has like a unique code, or let's say when you're given like an identity card, there's a unique code behind it, right? Example, let's say you were given fly 87, someone else was given like, I don't know, 639. Every person has their own unique code that you're given either during birth or when you're giving an ID, or when you're given like an ID, okay? But let's say during birth, okay? So when you get to now the club, okay, the bouncer won't have to ask for like an ID from you, and the bouncer will be like, what's your code? Okay, because then he knows every person has that unique code that they were given, let's say by the government during birth, okay? So I'll give out my code like fly 87. And then this bouncer will check it against the government's database, because obviously government has like a database of the people in their system, right? Here in Kenya, it's called, example, let's say we go check in e-citizen or something, right? Let's say we have like a citizen database which is being run by the government, okay? So this bouncer will input that secret code, example, fly 87, right? And then now, instead of coming with your details, it will just verify that, okay, this person is over 18. Okay, and then the bouncer sees that and is like, okay, you can come in. All right. So where does the ZK come in? I've been able to prove that I'm over 18 without the bouncer seeing my ID, knowing my name, where I was born, or if it's like birth certificate, all these other things, right? So I've been able to prove that I'm over 18, and I haven't had to like submit an ID. Okay, that's the whole essence of ZK in itself. Okay. Oh, okay. Let me go back. The whole essence of ZK is you're proving that you know something without having to without having to show the proof. Okay, it's like I'm saying, I let me look for another word. It's like I'm saying I know your password, but I don't have to share your password to know that I know your password. But to avoid confusion, let's just go with this, right? I'm able to prove that I'm over 18 without having to, okay? So there are several principles around that when you now come to ZK, because example, we have the prover who is you as the guest, okay? Because you're now submitting that you're over 18, and the secret is your ID, okay? Because you don't have to show your ID, because once you show your ID, it's like you're showing your secret, okay? We know ID is private. I want to just show people that I'm over 18, but I don't want them to see my ID. How do I do so? That's where ZK comes in, right? So we have that secret, which is like your ID details, right? Your bouncer will be like a verifier. Their work is just to prove, to confirm that really you're over 18, okay? And yeah, principles that we have behind the case. So you can show something without having to like submit the secret in itself. Okay, just like how we've said in the club, you can prove that you're over 18 without having to introduce your ID. So when you see ZK at a higher level overview, because it obviously has like a deeper level aspect to it, and also we can come and we can discuss more in details about how Starknet is able to like implement this. But essentially, that's the whole concept, right? When you see ZK, always remember, when I'm going to the club, I can prove to the bouncer that I'm over 18, but the bouncer doesn't need to see my ID. Okay, that's the whole aspect of ZK. I wanted to like introduce that in very simple, relatable terms. Okay, so with that, I had there's something else I wanted to show you guys. Like example, we can, let me see. Yeah. If I do so, will it, let me first, okay, so with that I had like a very simple game I had to I was trying to show you guys, because one thing I was thinking about is, okay, let's say I've submitted a code to the bouncer, okay? I mean, if I'm what is the difference between this and between ZK and example brute forcing, okay? Because I can guess, I can like, okay, this one hasn't worked. Let me guess this and say maybe fly 29, fly this. I can keep on guessing until I get it right, right? So what's the difference between now ZK and something we call brute forcing? Because I can like I can do trial and error until I'm able to prove that I know the secret, right? So with that, I had like I had like a some two games. Example for this, I'll input like the way we work here is, so I hope I can like have you guys participate, right? So I'll input like a secret password here. You're not going to be able to see it. Let me just, oof, what has happened? Okay. Yeah. So I've inputted like a secret password. Yeah, you haven't been able to see it, right? So I'd like you guys to try in the chat, just make wild guesses of whichever password like I've tried to input, right? You can just put anything so that we can try it. And then if it matches, you've won the game, right? So yeah, you can just input anything you think I've added as a password. Okay, let me see. Fly 444. Let me start with fly 444. Okay, so fly. Okay, let me come back here. Fly 444. Let me just. Oh, I'm doing so. Yeah, wrong guess. Okay, so the whole aspect of this game is, I don't know if you recall the dinosaur. I got the inspiration from like the Google dinosaur game, right? So it's like with every wrong attempt, the cactus is getting closer to the dinosaur. And so we have like 4 attempts left, right? And then if no one is able to like guess correctly the password which I input, we have like a game over, right? So that's the first attempt. So let me just randomly pick another one. Starknet 123. Okay, so let me just input that. Starknet 123. Yeah, another wrong guess. Okay, let me see. So the cactus is edging closer. So we have 3 attempts left. So let me see. Ha, Cyndie ZK. Okay, let me use Cyndie ZK. Okay, so Cyndie ZK. Nope. Decentralization. But oh no, you guys are overthinking. It's so simple. Okay, 0003. 0003. Oops, wrong guess. Let me see. Cairo, okay. Oh, game over. Yay! Christine got it right. I actually put 1, 2, 3, 4, 5. Oh, nice. So Christine got it right actually. Yeah, I had input 1, 2, 3, 4, 5, right? Yeah, so that's the whole, okay, so the whole aspect of this game is, example, let me just run it again. So of course, let me just tell you, I put 1, 2, 3, 4, 5, right? So if someone comes and guesses correctly, 1, 2, 3, 4, 5. Remember, it's not like they've seen my password, it was secret, right? But they've guessed 1, 2, 3, 4, 5, and they're like, yay, you got the proof. That doesn't mean that they actually knew my password. They were just trying, right? So sometimes it can be confusing with VK and brute forcing, because especially when you think about it in a higher level overview, because in my mind, I'll be like, what if I try proving that I know this secret until I get it right? Doesn't that diminish the whole aspect of ZK, right? So with that, let me see where I am. Yes, ZK Club. Okay. Yeah, so with that, I decided to like create a simulation. The way ZK works is we assume that already you know the password, and it's like, let's say you have just one chance to prove that you know the secret, right? Otherwise, if you don't know, that's it. Okay. Example, the way I was talking about the secret club code, you can't start coming here and like just guessing. Okay, let me just say that, right? So it's the same thing. Oh, okay, don't worry. These are some of the program is still work in progress. Just run it again. Yeah. So with ZK, it's not trial and error, right? You can't come in and start stammering at the club when you asked what is your code, right? At the same time, just like how you start when you start stammering when the bouncer asks for your ID, they won't even wait, they'll kick you out, right? So in ZK, it's either you know or you don't know. There's no trying out the way we were trying out and guessing right now that and then by pure chance you're able to like guess the secret password, right? That's not how ZK works. That's why I wanted to show you guys the difference between ZK and example brute forcing. Okay. So example, if I come here and say my code is like GH87 or something, GH. Yeah. So in my program, it's having like a lot. This is like a screen rendering issues because of the Rust crate I'm using. Okay, so yeah. So of course I had coded some of the codes which you'll be using. It's just that the one that's coming in my mind right now is Fly 87, right? I had coded some of the codes in like my database, in my virtual database, in the program that I'm writing. Okay, but essentially, this is how it works. Okay, so we've inputted my code, and the bouncer hasn't seen my ID or anything. They've just seen like, okay, this guy is over 18. Maybe the database was like, this guy is over 18, and that's it. Okay, and with that in mind, I had another question for you guys. So remember, this bouncer. Let me just make it like a slideshow. This bouncer, it's not like they're saying my ID, right? So what if I ask my friend who I know he's over 18, give me your unique code, right? And then I go and say it to the bouncer, and then the bouncer doesn't know my name or anything. The database will just show them I'm over 18. Okay. So how do we protect such a system in a way that if I come with the code, if I say like I know the secret because let's say I can go and borrow like the proof which I'm submitting for verification that I know the secret, right? So how do we protect our system against this in a way that if I go to with a secret, if I go with like a unique code which is not mine, I've borrowed from like my elder sister or something, and I'll still be allowed to enter the club because the database will say I'm over 18, but the code is not mine. So I wanted to see any ideas you guys might have of how we can be able to have a workaround on that, considering the fact that remember the bouncer can't see your ID. Yeah, let me see. Do you guys have any ideas around that? You can deliberate on that and see. In the meantime, let me check if we have any questions. Okay, passkeys. That's nice. Let's see if we have any questions as I wait for you guys. Okay, so fingerprint, nice. Biometrics, nice. We can use nullifiers. I'd love to hear more on that. Session keys, 2FA, security questions. Yeah, you guys are very nice. Verifying biological proofs. You guys are nice. Okay, so actually this is like don't think about it in ZK. We were talking about like the bouncer scenario, okay? We'll talk about it more when it comes to blockchain, okay? But essentially, you guys are right. So How do we verify this? Ooh, right? So let's say each code operates with like the biometrics, what you've talked about, right? So if I come and give my code to the bouncer, let's say fly 87, because that's what I remember, fly 87, right? And then the bouncer comes and scans, let's say, my fingerprint or my iris or something, right? And then it confirms that I'm the owner of this I'm the owner of this unique code, right? And I'm over 18 and I can enter. That avoids a scenario where someone else can borrow a code from you and then use it and impersonate themselves as you, right? So that's just something I wanted to talk about. I think we'll talk about this more in terms of Starknet technology and how it's able to have these design trade-offs, like ensuring if you're like submitting a proof of something, we need to verify that it comes from you. Okay, so that's something we can talk about tomorrow. So it was just like a quick overview in light of tomorrow. So tomorrow I'll share with you guys, we'll go through this analogy of ZK again, and then I'll connect it with how Starknet is able to apply ZK and have such trade-offs in terms of ensuring that whoever's submitting the proof, for example, in light, speaking on a higher overview, whoever's submitting the proof claims to be who they are. Okay, yeah, but essentially we'll just use biometrics, right? So let me see. Yes, I'm also waiting for Truth to tell us more about nullifiers. For nullifier, once you've used it once, you can log your picture with the hash of the nullifier so no one else can use it after that. That's interesting. I'll go read more on this, right? So they can log your picture with the hash of the nullifier so that no one else can. So thank you, Truth. I think we can go read more on nullifiers, right? But essentially, I was just thinking of a very, very simple solution, fingerprint, okay? And it's not like even if you put your fingerprint, it's not like the bouncer will know your details or anything. It's just confirming that you're the owner of the unique code. All right. Yeah. So that's the presentation I had today. So we just a quick recap. Remember, we started with like introduction to blockchain. We went through the blockchain principles, which is node, consensus rules, Byzantine fault tolerance, the peer-to-peer system, game theory for incentivizing people, ensuring that the blockchain is immutable, privacy through hashing. Have I missed something? Yeah, I don't think I've missed something, but those are some of the principles. So if you're like designing a blockchain system from scratch, those are some of the primary principles that you have to apply for your blockchain to be like blockchain. Okay. Yeah. So those are like, that's like the foundation of how many blockchain, like many chains, etc., they are designed. Okay. So when you, that's why we had to talk about principles. So once you understand like the principles, you'll be able to like understand some of the design trade-offs which are made during the blockchain system, right? We've also talked about the public key, private key for wallets, shown you guys how hashing works in real time. And yeah, we've gone through ZK. So yeah, do you guys have any questions? Any questions, comments, criticisms? Let me just, why am I not seeing?
GM, sorry, am I audible enough?
Yes, you are, please.
Hey, good. Hello. Yeah, nice presentation. I just want to say thank you for the class. But what I didn't get is that what if statements or that you said previously. I didn't really understand that part. So maybe you should just go over it again for me. Thank you.
Wait, repeat again. Which statement? Let me just note it down so I don't forget.
Yes, you said
What?
something about what if Starknet was something. What if I missed that.
Oh, okay. Okay. So sorry, it's I was supposed to like change the topic headline. I forgot. So it was just like a quick overview. I wanted to share it like next slide in tomorrow's slides, but I sort of mixed them up. But yeah, for this, we'll talk about it more tomorrow because tomorrow we'll go into a deep dive into Starknet. So just don't mind this one, honestly. Let me just don't mind this. I'll talk about it tomorrow. I actually forgot to like change the topic headline. Yeah. Is that okay? So I'll go into like deeper details about this tomorrow when we now enter into now Starknet as an architecture, etc.
Okay, that's fine. Thank you.
Yes. Sorry about that. Yeah. Okay, so
Okay.
any other
GM,
questions?
GM. Yeah, GM, everyone. Can you hear me?
Yes, we can hear
Please,
you.
am I audible enough?
Okay. Yes, you're audible.
Okay.
What was I looking
Sorry,
for?
thank you for the knowledge you really impacted. It's greatly appreciated. Thank you very much.
Okay.
Actually, I came late. I missed the first part, so I joined through the second part because I was not settled enough. That is why. So I joined late. I don't know if this space is recorded.
Yes, it is. Yes, it's recorded.
So possibly we'll get the recorded video link in the group.
Yes, it will be posted tomorrow morning. Yes.
It will be posted tomorrow morning.
Yes.
All right. Thank you very much. Thank you.
Okay, so I found what I was looking for actually. So remember when I was sharing with you guys the ZK Club, I told you guys I had coded the codes, right? That's why I was forgetting. So let me just remember which 64. So I wanted to show you guys what if you show like a code and you're not over 80 something. So let's go back here. Oh shit. Okay, yes. What was the code again? Wish 64. Right. Wish 64. Yeah, user is a 19. I just wanted to show you guys like that. So that's how like the ZK system would work. Okay. Do we have any other questions? So if the repo is public, yes. So for this, Anders Brownworth is actually a very good repository. So here it is. I can share it also in the group. It was made like 8 years ago, but I always love it a lot because it's so nice when you like introducing blockchain, how blockchain works. So yeah, you can go play around with it. This guy made it like 8 years ago, so I can like share this. Oh, this is actually public private key demo. So fucking hell, I've forgotten it. Where was it? And I had it. Okay, when I get that exact repository, I'll share with you guys. This is like this is like the web version of it. But if you want to go tinker with the code, etc., it's JavaScript, so you can go tinker. Okay, wait, I'm low. Where's okay. It's actually what's it called? It's actually it's what's it called? It's open. Yeah, it's public. Yeah, so let me just share it. Yeah, so that's it. Also for the slides, I'll share them in the Telegram group also. No, we didn't write these codes today. I had configured the game before. Like I had made it some few hours back. Okay. All right. Yeah. Do you guys have any other questions?
Oh,
Yeah, with
GM,
that, I think we can.
sorry, am I audible?
Yes, you are.
All right. So my only question actually, first of all, thank you for this section. I've been in the course since the beginning of the section, and it has really been very, very insightful. But my only question is this the consistent character you use in the slides. I don't know if you can like share, is there a tool you use in making those consistent cartoon characters? Because it's really, really nice. I'd love
Okay.
to.
Okay. Oh, this consistent. All right. So what I actually use is I use Midjourney. Let me just go to Midjourney very quickly.
Okay, Midjourney. Okay.
Yes. So what I do is, normally I come up with like a concept plan, like a storyboard, right? So for create, I had to like, these are other contents I was creating some time back. Um, So I'll actually this content I had created like an animation. I can play it. It's like a 1 minute animation talking about the Starknet architecture. So we can go through it tomorrow. So what did I? Yeah. So this slide here, right? So normally it's just trying to. There's this thing we call. There's this there's this flag that we input. When I remember the specific flag, I can't find it here. Is it sref? Yeah, it's sref, right? So if I create like a specific image, right? Like let's say I have this image, you can see they are very consistent. Okay. So I provide some sort of reference material to it. Here, as you can see, I've been providing reference materials to it, and I tell it to like go with the theme. Okay, if the theme is this dark, neony, and this sort of animation style, like this one, I got the inspiration from, I don't know if you guys know Kuruzegast. Kuruzegast, or is it Kuruzegast? Something like that. Let me just. Yes. Channel where you learn a lot of stuff using animation. So it's very nice because you learn a lot of things and you also like enjoy the animation, the way they create it. Like this is it's so nice. As you can see, they get a lot of views. So I got the inspiration that, and I'm like, okay, when it comes to like Web3 content, a lot of really nice content that people can learn about Web3 and also enjoy. So that's where the whole animation point of view came from. So I just used to like prompt my Midjourney to sort of emulate get inspiration from like Kuruzega style tomorrow. But yeah, I just use it. So to be able to have the theme, which I have here, where as you can see, the themes are like they're all aligning. That's what I did. So you give it an image to give it some sort of reference, and then Midjourney is so nice. It tries its best based on the prompt that you've given it to stick with the same theme. That's how I had like a consistent character. That's how I did it.
All
Have
right.
I answered your
Thank you
question?
so
Okay.
much. Yeah, thank you so much. I really appreciate it.
Okay. All right. Any other
Um,
questions?
Yes, I guess maybe other questions will be asked on the Telegram channel. So we are like used extra 40 minutes. Okay, so thank you so much, Cyndie, for that brilliant session. That was really amazing. Thank you so much. And thank you everyone for joining as well. Like we mentioned before, if you have questions, more questions, please don't hesitate to ask on the Telegram channel. I'm going to drop Cyndie's Telegram username in the Telegram channel, so you could tag her, and even if she's not available, there are other people that would answer your questions. And yes, so we have come to the end of session 1 for this week. That's the fundamentals week. Tomorrow we're going to be continuing. We're going to wrap up things, right? The same time, 5 p.m. UTC, don't come late. We're not going to start late. We're going to start very early so that we can finish up on time. And all the resources are going to be shared on the Telegram channel, the slides, onboarding session, and every other thing that you need will be shared on the Telegram channel. Yes, so I'll see you guys tomorrow. by 5 p.m. UTC. Have a great night, and thank you, Cyndie, once more. See you tomorrow. Yeah, bye,
Bye. See
guys.
you
Bye,
tomorrow.
everyone.
Bye.